All right, so you guys have already watched a video on how to identify how many SigFigs a number has, how to round a number to a specific amount of SigFigs, but today we're going to talk about kind of the why. Why do we need to round to a specific number of SigFigs? And so we're going to do calculations with SigFigs. So just remember, the reason we have SigFigs is that you cannot report a measurement that is more precise than your measuring device allows. Okay? But what we end up doing with those measurements is a lot of times calculations, right? Which involve numeric or algebraic operations, multiplication, division, addition, subtraction. So we cannot use a measurement in a calculation and then report the answer to that calculation with more precision than the original measurement. So we have to have rules dictating how many SigFigs are numbers that are our answers that can have based on your original measurements. Okay? So it's a little complicated, but it's basically just because we cannot calculate a number that is more precise than the measurements we used to calculate. So here's the first rule, and it's a rule for multiplication and division. Now hopefully you can kind of deduce why we have the same rule for multiplication and division. Good, it's because they're just inverses of each other, right? If you multiply and divide, those are opposites of each other, so they're theoretically like the same operation, just the inverse. So we're going to do the same rule for multiplication and division. And the rule says that the amount of SigFigs in your answer should be equal to the smallest amount of SigFigs from the problem. Okay? So, for example, and I think it's easiest just to see this in an example, let's take 6.5 times 1.355. Now, if you look at this number, this has precision to the tenths column. Here we have precision to the tenths, hundredths, thousandths column. So if we're going to do this operation of multiplication, we are not going to allow our answer to have more precision than our numbers that we plug in. So for multiplication, how that works out is we will look at the total number of SigFigs from each number in the problem. So how many SigFigs does 6.5 have? 2. How many does 1.355 have? 4. So when we calculate this, our answer can only have the amount of SigFigs equal to the smallest amount from the problem. That is, of course, 2. So if you plug this in, your calculator will give you 8.8075. But we know that that's too many SigFigs. That's 5. We can only have 2. So we're going to have to cut it off. This is where the rounding part comes in, right? So we're going to cut it off between this 8 and the 0. That 0 will obviously not change that 8. And so your final answer must be 8.8. Okay? Let's try one more. How about if we do 23.3 divided by 101.33. Again, look at your numbers that you're plugging in. This has 3 SigFigs. This has got 5 SigFigs. Therefore, your answer better only have, good, 3 SigFigs. So if you plug that in, you would get some gross number like 0.22994. But of course, we cannot have all of those significant digits. We can only have 3. So we'll go 1, a 2, a 3. We'll cut it off right there in between the 9 and the 9. And this is going to be a little tricky, but if you rounded that, it would be 0.230, right? That 9 is going to bump that up. So that's going to become 10, which is going to bump that 2 up to a 3, and you're going to leave this as a 0, but it is a significant 0 because it's trailing, it's at the end, and there is a decimal anywhere in the number. So that's our 3 sig fig answer. Okay, on to addition and subtraction. Again, they're going to have the same rule because they are just inverse operations of each other, but it is a different rule than multiplication and division. So the rule here is that your answer should have the same amount of numbers past the decimal as the smallest amount from the problem. So now it no longer has anything to do with total number of sig figs from the problem. Now all we're looking at for addition and subtraction is how many numbers after the decimal the numbers from the problem have. Okay, so let's show this with some examples. We're going to use the same numbers, just a different operation. So we're going to have 6.5 minus 1.355. Right, that's a simple calculation. You can plug that into your calculator and it would give you 5.145. Except this rule says that we can only, in our answer, have the same number of digits past the decimal as the smallest amount from the problem. So just look at how many numbers past the decimal each of these inputs have. Here, we only have one number after the decimal. Here, we've got 3 numbers after the decimal. Therefore, your answer can only have 1 number past the decimal. So that just tells you where to cut it off. You still have to round just like normal, but it's just going to tell you where to cut that number off to round. That 4 will keep the 1 a 1, and so your actual answer with sig figs is simply 5.1. Okay? Another one, let's do 23.3 plus 101.33. If we do that, you plug it in your calculator, it would give you, let's see, 124.63, right? Again, you're just looking at the numbers past the decimal. In this first number, we have 1 number past the decimal. Here we have 2. Therefore, your answer can only have 1 number after the decimal. We would cut it off between the 6 and the 3, and it would become 124.6. Now, these are just doing one operation, but you could have 23.3 plus 101.33 minus 15, okay? 2 operations occurring in this calculation, but they're both within the same rule, right? It's just a combination of addition and subtraction. Therefore, if it's all in the same rule, if every operation in the problem is just under the umbrella of the same rule, then you do your calculation, the entire calculation, and then round at the very end, okay? It's a little trickier if you're mixing the rules. We're not going to worry about that for now, but if you have multiple operations within the same rule, just do all of the operations according to your PEMDAS order of operations, and then round at the end, okay? So this one you would put into your calculator, and you would round to how many numbers after the decimal point? Good, it would be 0 in this case because 15 has 0 numbers after the decimal. Okay, so make sure you know these rules according to their operations because it will come up over and over and over and